Hi friends, in this video we'll discuss on aromaticity. Aromaticity is the characteristics of an organic aromatic compounds. The conditions or criteria that an organic compound will be aromatic in nature. So let's discuss all the four conditions one by one. First condition, the organic compound should be cyclic in nature. And second condition is the cyclic organic compound should be planar in nature. Third condition, the cyclic organic compound should have conjugation system. And fourth one, the cyclic organic compound should satisfy Huckel'Rule rule. That is 4n plus 2 pi electron. It should contain 4n plus 2 pi electron where n is equal to 0, 1, 2, 3, 4 etc. An aromatic compound should satisfy all the four conditions. If any one fails, then it will be not considered as aromatic compound. So, these are the some cyclic organic compounds. Cyclic organic compound means it will start with one carbon and it will end with the same carbon. These are the some organic compounds which are cyclic, can be aromatic compounds. You can't say all cyclic compounds are aromatic. To be aromatic, it should satisfy other three conditions also. The second condition is the cyclic organic compound should be planar. The compound should be flat and can be placed on 2D plane or on our blackboard. If any component or part of cyclic conjugated system will be below or above the plane, that will be not aromatic compound. Here is a prominent exception is the isomer of 10 alunyl below left structure. So although it is a cyclic conjugate system has 10 pi electrons, it is not flat due to the repulsion between hydrogen that arise when it is in the flat conformation. So due to the repulsion, it will be not present on the plane. Since it is not flat, it cannot be aromatic in nature. However, replacing this hydrogen, if we will join these two hydrogen by a bond with bonds to be bridging carbon, allow it to be on the plane. So it will be aromatic compound. So on the below of the slide, these are the some compounds which are not present on the plane. So this cannot be aromatic in nature. So coming to the another condition, the cyclic organic compound should have conjugation system. So this organic compound should have double bond, single bond, double bond, single bond. So double bond and single bond should be in alternate position in a cyclic ring. So this benzene is in conjugation system. So similarly, this structure double, single, double, single. Another structure, this is in conjugation double, single, double, single, double, single. In alternate double bond, single bond. So in the fused benzene ring, this is naphthalene. In a cyclic ring, you will see double, single conjugation system, alternative double bond and single bond. Also in case of anthracene also. So in conjugation, in place of double bond, positive charge, negative charge and lone pair can be in conjugation in place of double bond. So let us discuss this ionic species. This in negative charge, single, double, single, double, single. So negative charge in place of double bond, that will be in conjugation. Similarly, positive charge also will be in conjugation. Positive charge, single, double, single, positive charge. Also, here a negative charge, single, double, single, positive charge, single, double. So these are the different ionic species will be in conjugation. So you look at this structure. So in place of double bond, that will be in alternative position, positive charge and negative charge. So also lone pair also will be in conjugation. Here in the heterocyclic compounds, lone pair, single, double, single, double, single. So in case of pyrrole. So here furan is also in conjugation system. Also this cyclic conjugation system, lone pair in place of double bond. So these are the different organic compounds which are in conjugation, which have conjugation systems. So last and the most important condition is it should satisfy Huckel's rules. So to discuss about Huckel's rule, the system should have 4n plus 2 pi electron. How will calculate the total number of pi electrons in a system? So first we will calculate the total number of pi electrons in a given organic compound. So to calculate, we have to find out how many pi bonds are there. For each pi bond, we will calculate 2 pi electrons. For if in a conjugation system we have lone pair, that will be calculated as 2 pi electrons. If we have negative charge, that will be calculated as 2 pi electrons. If we have positive charge in conjugation, that will calculate as 0 pi electrons. So calculate all the pi electrons, put in the equation 4n 2 pi electrons is equal to total number of pi electrons. Let's assume x pi electrons. So if we will get the value of n is equal to 0, 0, 1, 2, 3, 4, etc., then they will satisfy Huckel's rule. So negative charge, for negative, just remember, for negative charge this is 2 pi electron, for positive charge 0 pi electron, for lone pair 2 pi electrons. So in this way we will calculate number of pi electrons and we will find out value of n. So value of n cannot be negative or fraction, then that will not satisfy Huckel's rule. So these are the different systems which are in conjugation. So let us find out number of pi electron in this type of systems. So here benzene, in case of benzene we have 3 pi bonds. So 3 pi bonds means 3 into 2, 6 pi electrons. Here is the another system. We have negative, single bond, double bond, single bond, double bond. We have 2 pi bonds, 2 pi electron, 4 pi, and 1 negative charge, 6 pi electron. So in this way, in these systems, you will calculate yourselves number of pi bonds, pi electrons, and put in the Huckel's equation 4n plus 2 pi electron, find out the value of n. Aromatic compounds can be generally classified in two types on basis of appearance of benzene. If the aromatic compounds look like benzene, these are benzoates. If not, it will be non-benzoates. In case of benzoate aromatic compounds, benzenes and polycyclic aromatic compounds like naphthalene, anthracene, phenanthrene like this, and benzene adds its derivatives, toluene, phenol, etc. In case of non-benzoate types of aromatic compounds, comes under heterocyclic compounds, annulenes, and ionic aromatic systems. Let us discuss all types of aromatic compounds one by one. First, benzoate aromatic compounds. Benzene is a monocyclic benzoate aromatic compound. Here naphthalene and anthracene and phenanthrene. Let us discuss about the aromaticity of these benzoate aromatic compounds. Let us check and justify these are aromatic or not. First, benzene. So this is cyclic, obviously planar, having conjugation system and satisfy Huckel's rule, having 6 pi electron, 4n plus 2 pi, 6 pi electron, n value is 1. So it is satisfy Huckel's rules. So benzene is aromatic compound. Let us discuss about naphthalene. This is cyclic planar conjugation and satisfy Huckel's rule. 4n plus 2 pi, total number of pi electrons is 10 and value of n is 2. Then let's discuss about anthracene. So obviously it is cyclic planar conjugation and satisfy Huckel's rule, having total 14 pi electrons. So value of n is 3. So if we will discuss about phenanthrene, same as anthracene, it is cyclic planar conjugation and satisfy Huckel's rule, 14 pi electron. Value of n is 3. So if we will discuss about non-benzoate aromatic compounds, first we will discuss about heterocyclic compounds, pyridine, pyrrole, furan and thiophenol. In case of pyridine is a 3-pi system, 3 pi bonds in alternative systems. So this is cyclic, planar, conjugation and satisfy Huckel's rule. So remember, in case of pyridine, this lone pair will be not included in conjugation. So total number of pi electrons is 6 pi. Total pi bonds 6 pi electron. 4n 2 pi is equal to 6 pi, n value 1. In case of pyrrole, listen, this is cyclic planar conjugation and it satisfies Huckel's rule. Total number of 2 pi bonds is equal to 4 pi electrons, 1 lone pair, 2 pi total 6 pi electron, 4n 2 plus 6 pi, n value 1. Similarly, furan, this is also cyclic planar conjugation and satisfy Huckel's rule. So having 2 pi bonds, 1 lone pair, total 6 pi electron, value of n 1. Similarly, we can justify thiophenol is also an aromatic compounds. So these are the different heterocyclic compounds which are aromatic compounds, and these are coming under non-benzoate aromatic compounds. So these are the heterocyclic. This is all about heterocyclic compounds which are aromatic in nature. So this is same pyridine. The lone pair is not the part of pi bonds. So in case of pyrrole, this lone pair is the part of pi system. So in case of furan, also one lone pair is the part of conjugation system. So we will calculate that lone pair which is part of conjugations. So now we will discuss the non-benzoate compounds which are ionic species. So first, cyclopropenyl cation. Listen, positive, single, double, single, positive. So this is cyclic, planar, conjugation and satisfy Huckel's rule. Listen, for 1 pi bond, 2 pi electrons, for positive charge, 0 pi electrons. So total number of 2 pi electrons. Here 4n plus 2 pi is equal to 2 pi electron, value of n 0. In this situation only, value of n will be 0 in Huckel's rule. So next we will go to cyclopentadienyl anion. Listen, negative, single, double, single, double, single. So this is in conjugation. So this is a 5-membered ring, and here listen, this is cyclic, planar, conjugation, satisfy Huckel's rule. 2 pi bonds, 6 pi electron, 1 negative charge, total will be 6 pi electron, value of n will be 1. So in case of cyclopentatrienyl cation, this is a cyclic 7-membered ionic species having positive charge. So this is also in conjugation. Listen, cyclic, planar, conjugation, positive, single bond, double, single, double, single, double, single, positive charge. So total number of 3 pi bonds. So 6 pi electron for positive charge, 0 electron. So total will be 6 pi, value of n will be 1. So these all 3 ionic species are aromatic compounds. Although it is not the benzene structure, but this is aromatic compounds. Another type of aromatic compounds are quasi-aromatic compounds. The aromatic species whose charge contributes to the aromaticity of compound are known as quasi-aromatic compound. Quasi-aromatic molecules are not aromatic in their neutral form, but are aromatic in their charged form. So, let us discuss about cyclopropanone system. This is a cyclic carbonyl compounds when it will form in ionic form. As we know, carbonyl functional group is polar in nature. Carbon having partial positive charge and oxygen will possess partial negative charge. So this part will be cyclopropenyl cation and this will be aromatic in nature. So the total compound will be aromatic in nature. Let us discuss about tropone. This is cycloheptatrinone. So, in ionic form, this cyclopropylium cation will be aromatic in nature. So, whole aromatic compound will be aromatic in nature. So, these are the compounds in ionic form. In charged form, this will be aromatic in nature. So, these are the known as quasi-aromatic compounds. So let us discuss. These are the different quasi-aromatic compounds. If we look at the properties of organic compound, this quasi-aromatic compound, these are crystalline in nature, highly stable, high dipole moment. So if you look at this molecule having both positive charge and negative charge as ionic species, so we can see high dipole moment. So these are due to crystalline in nature, having high boiling point and melting point. These are soluble in polar solvent. Although it is our organic compounds, it should be non-polar in nature, but due to this quasi-aromatic nature, these are soluble in polar solvents. Some molecules are aromatic after breaking. After breaking of this molecule in ionic form, this organic compound will be aromatic. This type of compounds are known as fulvalin compounds. So let us discuss this compound. This name of this compound is calicini. This is an aromatic compound. If we will break this compound, this will form in two different ionic species. So first part will be aromatic. Obviously second part will be aromatic in nature. So whole organic compound will be aromatic in nature. First one is cyclopropenyl cation. Second one will be cyclopentadienyl anion. Both are aromatic, so whole compound will be aromatic in nature. We look at this another structure, cyclopentadienylidyl cycloheptatri. So if you ionize this compound, it will look like this. So first part is aromatic, although second part is also aromatic. One is cyclopentadienyl anion, another will be cycloheptatrinyl cation. Both are aromatic. Both aromatic compounds join with each other. Whole organic compound will be ionic in nature. Azulene is special type of non-benzoyl aromatic compounds. It is a fused ring, 7-membered and 5-membered fused ring. So this is if you ionize azulene, it will convert into cyclopentadienyl anion and cycloheptatrinyl cation. So as both are aromatic in nature, so the azulene compound will be aromatic in nature. So azulene exists in two ionic form. So this is highly polar compound having high dipole moment. Cycloheptatrinyl cation, this is also aromatic compound, and cyclopentadienyl anion, this is an aromatic compound. So azulene is a blue solid, readily undergoes electrophilic substitution like other aromatic compound. So it is a combination of cyclopentadienyl anion and cycloheptatrinyl cation. So let us classify aromatic, anti-aromatic and non-aromatic compound. As you know, an organic compound will be aromatic nature if it is cyclic, planar and conjugate. If it will have 4n plus 2 pi electron, then it will be aromatic. Suppose it will satisfy all the conditions cyclic planar conjugate, but instead of 4n plus 2 pi electron, if the organic compound will have 4n pi electron system, this will be regarded as, this will be considered as anti-aromatic. So if all the four conditions, any of these four conditions will not meet, one will fail, then these compounds will be known as non-aromatic compounds. So cyclic planar conjugated 4n 2 pi electron, these are aromatic compound. 4n pi electron, both classes meet these criteria. Only 4n plus 2 pi or 4n pi electron will differ. If it will have 4n plus 2 pi electron aromatic, 4n pi electron anti-aromatic. If among all the four conditions, any one or any two will fail, then this will be non-aromatic compound. So in this context, benzene, pyridine, naphthalene, both are 6 pi electrons and 10 pi electrons, so these are aromatic. So in this case, so we have 4 pi electron, so these are anti-aromatic 4n pi system. So here, not fully conjugated, not planar, so these are non-aromatic. So if you will see the stability of aromatic, anti-aromatic, non-aromatic, aromatic is more stable than non-aromatic, and non-aromatic is more stable than anti-aromatic. So anti-aromatic compounds are least stable, so having 4n pi systems. So let us discuss about naphthalene is aromatic due to planar in structure, but in the exception 10-annuline is a non-aromatic nature. So although it have 4n pi cyclic conjugate and a planar, but it have 4n pi electron, but it is not remain in the plane due to the steric hindrance of this hydrogen group. So 10-alunyl is non-aromatic compounds. So if we discuss about cyclo-octa tetraene, so this can be called as COT. So this is having conjugation system. So this is cyclic, this is planar, having 4n pi system, but it is not anti-aromatic, it is non-aromatic. The reason is that it is looks like planar, but it is not actually planar. So this is aromatic? No. This is anti-aromatic? No. This is non-aromatic. As why this is so? Because cyclic, planar, this is not planar. Having conjugation system, no doubt. Having 4n pi system, yes. But cyclo-octatetraene COT remains in stop shape, non-planar shape, because in non-planar shape it is more stable, having 10 kilocalorie more stable than planar structure. That's why COT is not aromatic, not anti-aromatic, this is non-aromatic in nature. So this is the reason why we can consider COT as non-aromatic compounds. Next, these are the some compounds, annulenes, which are aromatic, non-aromatic, anti-aromatic. So 2-annuline having 2 pi bonds, that's why this is anti-aromatic, and 6-annuline benzene itself is aromatic, and other 8-annuline are non-aromatic. So these are the examples of some aromatic and non-aromatic compounds. In this way, we can judge or justify some aromatic compound by using aromaticity concepts. So we are already discussed ionic species, non-bonjoid structures, and fused structures, etc. So in the next video, we will discuss different questions asked in IIT JAM, GATE, CSR, different entrance examination asked related to aromatic compounds. So till now, We'll see you in the next video. Please watch our second part of aromaticity compound that will be totally in the question answer manner. So thank you very much.